Hi, let's now look at question 3 of the numerical integration worksheet. So question 3 says approximate the following integrals using the composite trapezoidal rule. That is, we have A, okay, we have A, B, C, okay. Then the second part is D, which says determine the value of n and h required to approximate the integrals in A to C, like on all of them, to within this um, margin of error that we are given, that is 10 to the power negative 5. Okay, so what I'm going to do is that I'm going to pick one, work it out step by step, then in the same order you can try out the others, then we can see how we can like reason from there. I'm going to leave the link of my WhatsApp in the description so that when you have worked this out, whichever that I'm going to leave out, you can get in touch with me and we'll be able to compare solutions. Yeah. So let's look at which one am I going to pick. Let me pick question 3a. Okay, that is the definite integral from 0 to 2 of a rational expression 2 over x squared plus 4 dx, and we're given n is equals to 6. So what I'm going to do is that I'll do a, okay, I'll do 3a, then I also do part D for A, because part D you have to do for A, B, C. So meaning for D I only do for part A because I'm solving part A only. Okay, then part B, part C, you can try to work it out. You can get in touch with me through the contact that I'm going to leave in the description, then we'll reason from there. Okay, so let's work this out. So question 3a, we are given this integral right here from 0 to 2. It's 2 over x squared plus 4 dx. And one thing you're also told is that your n is equals to 6. Okay, so the first thing that I'm going to do here is to try to come up with the exact value. Okay, I'll try to come up with the exact value. So well, the reason why I'm trying to come up with the exact value is because I want to find the error at the end. Okay, of course it's not required, but like the question is not really asking for us to find the error, but it's a requirement for you to find the error, even though the question hasn't really stated. So it's important that you try to come up with the error of which you have to find the exact value. So this definite integral here, let's try to integrate and see what we're going to end up with. So what I'm going to do is to perform some substitution. Okay, so I'm going to let u be equals to x over 2. I just want to simplify this, meaning my du will be equals to 1 over 2 dx, like that. Okay, meaning my dx is equals to 2 du. Okay, so I'm going to leave the limits the way they are. I'm not going to change them and write them in terms of u, because I will still have to reverse this back again into x for me to do the evaluation. Okay, so here I'm going to write 0 to 2. Okay, but remember, while you have your dx here, you're going to put du, and you have a 2, so this 2 is going to multiply by this 2 that is right here. Okay, so this is going to be 4 divided by, so here you have x. What is our x? From this expression right here, you observe that your x is equals to 2u, meaning if you say x squared will be equals to this squared, and that is going to be 4u squared. So that will be 4u squared plus 4 du. Okay, and if you simplify this further, you're going to find that the 4 is going to cancel on the numerator, as well as on both the both the parts on the denominator, because you're going to factor it out. So just going to end up with 1 over u squared plus 1 du. Okay, without even wasting time, we observe to say from inverse trig functions, this is just the integral. I mean, like, this is just a derivative, rather. This is the derivative of uh, what can I say? Uh, if you have tan inverse, if you differentiate it, you're going to end up with that. Okay, you're going to end up with that, meaning if you integrate it, you're going to get back to what? To get back to tan inverse. So it basically means our this O part here is just tan inverse of what? Of u. Okay, and I'm trying to evaluate it from 0 to 2. But remember, I'm not just going to plug in just here, no, because that initially these limits that I'm given, they are not in terms of u, they are in terms of x. Okay, so I'm going to say tan inverse or arctan, my u is equals to x over 2, like that. Then I can do my evaluation from 0 to 2. So you're going to say tan inverse of, if you plug in 2 here, that is 2 over 2, that would be 1. So it's tan inverse of 1 minus tan inverse of 0. Okay, so remember to say your calculator is supposed to be in radians, and if you perform this the right way on your calculator, you punch that on your calculator the right way, and ensuring that it's in radians, you're going to end up with some value that is something like 0.7853 98163. Okay, so that's the value that we get as like that. That's our exact value. Okay, I've not really rounded it off, I've just gotten it the way it is on the calculator. So now let's apply the composite trapezoidal rule. So this is our exact value. Okay, this is our exact value. So let's find our approximation using the composite trapezoidal rule. So the formula for the composite trapezoidal rule is given as from a to b of f of x, which we already have, dx. This is approximately equals to h over 2. Then in the brackets you have f of a plus 2 multiplied by like the summation of f of xj. On top here you have n minus 1, then here you have your j starting from 1, then here you have your f of b. So all of this, like, I'm just going to use this part here, like the approximation. I'm not going to have to write the error part here. Okay, so one thing we observe is that we need to know what our n is. We need to know, actually our n is already given. Our n is 6 in this case, so we just have to find our h. Okay, so the way you determine your h in terms of the trapezoidal, the composite trapezoidal rule is that your h is just equals to b minus a divided by n. Okay, what is your b in this case? Your b is a 2 minus 0, which is your a, divided by your n, which is a 6. That is 2 divided by 6, that is 1 over 3. So our h is equals to 1 over 3. Okay, that's one thing. So our h is equals to 1 over 3. So another thing that we have to keep in mind is this part, because that's the one there where there is a lot of work. Okay, so if you substitute here, where there's n you plug in 6, you're going to have 5, because that would be like 6 minus 1, that will give us 5. Okay, so this is going to be 5 right here. Then here you have f of x sub j rather. So x sub j is equals to a plus j h. Okay, our a is a 0. Okay, so here it simply means we're just going to say it's j multiplied by h. What is our h? Our h is 1 over 3. So this is simply equals to j over 3. That is our f of, that is our x sub j. So we can actually substitute it here and just put f of j over 3 like that, and we have a plus here like this. Okay, so we can easily work out f of a and f of b. Why do I say so? It's just a matter of substituting a in this function as well as b in this same function. So how do we do it? So if you come and say f of a, what is your a? It's a 0, is equals to 2 divided by 0 squared 0 squared plus 4. That is going to be 2 over 4, which is simply 1 over 2. What about f of b? Our b is a 2. That would be 2 divided by 2 squared plus 4. That would be equals to 2 over 2 squared is a 4 plus 4. That would be 8. That would be equals to 1 over 4. So without even wasting time, we can plug it here. So that would be 1 over 2 for this part. Then this part we have 1 over 1 over 4. Okay, interesting. So now let's get to work the middle part that has the summation, and is the part that is a bit complex. So the way this can be written is that I can say I have a 2 multiplied by the summation of f of j divided by 3, starting from j is equals to 1 to j is equals to 5. Okay, so I can say 2 outside here. Okay, so it simply means I'm talking about f of, okay, f of what, j. Here if I plug in 1, meaning what this means is that I need to sum everything here up until I reach j is equals to 5, and I need to start from j is equals to 1. So we're going to say f of j, if it's j is equals to 1, that's just going to be 1 over 3, okay, plus f of, if you plug in 2, that would be 2 over 3, plus if you plug in 3, that would be 1, because that would be 1 over 3, plus if you plug in 4, that's going to be 4 over 3. The last one, that is going to be 5, that would be 5 over 3. Okay, so this is what the middle part means. Okay, so now what is this going to give us now? So here's how it's going to be. I'll start with this one first. F of 1 f of 1 over 3. So it simply means in your function where there's x, you need to substitute 1 over 3. So that's going to be 2 over, where there's x, you put 1 over 3. That's going to be like 1 over 3 squared plus 4. Okay, this is just more like 2 over 1 over 9 plus 4, like this. Okay, so what does this give us? Okay, what does this give us? You can make this a single fraction, so there's 1 here. So what you can do is that it's just simple algebra here, like this by that, this by this, and that by that. Okay, so what is this going to be? You're going to have a 2 divided by 1 by 1, like the major diagonal, that's a 1, plus 9 by 4. It's that's going to be 36 divided by 9 by 1 is a 9. Then you can like multiply this 9 with the 2 up there. It's just something basic, I think. So 2 by 9 is 18 divided by 36 plus 1, that's going to be 37 there. So it simply means for this part, okay, for this part, f of 1 over 3 is simply it's 18 over 37. Okay, let's work out the other part, and it's in these same steps that you continue with the rest. So here, f of 2 over 3. So even here we say 2 over, where there's x, we put 2 over 3. Remember, the squared plus 4 is equals to, we have a 2 divided by, so that's going to be 2 squared is a 4 over 9 plus 4 there, like this. So this is going to be, remember you have a 1, and all the same, this by this, this by this, this by that. Okay, so this is going to be 2 divided by 1 by 4, like the major diagonal is a 4, plus then 9 by 4 is 36 once again, divided by 9. So again, that 2, that this one here can multiply with that one, so that's going to be 18 divided by 36 plus 4, that's going to be a 40. So that can be simplified. Okay, that can be simplified. So we can say 2 into 18, it's 9. Okay, 2 into 40 is a 20. So we can say this part is 9 over 20. Okay, so let's look at the f of 1. Okay, so it simply means where there's x, you just supposed to substitute 1. So that would be 2 divided by 1 squared, which is a 1, plus 4, that's going to be 2 over 5. So that's basically 2 over 5. That was the simplest part. So we have 2 over 5. Let's get to f of 4 over 3. So we have 2 over 4 over 3 squared plus 4. So this is going to be 2 over, so that's going to be 4 squared is 16 over 9 plus 4. Once again, all the same, here, you just do this. 16 by 1, 9 by 4, 9 by 1. That's how we make that as a single fraction. So we have a 2 on the numerator, divide by 16 by 1 is 16 plus 9 by 4 we know is 36, divide by 9, but we don't really have to, yeah, okay, we say divide by 9, so that would be equals to, we have 18 on the numerator, divide by 16, 16 plus 16 plus 36, that's like 16, we have 36, what is this, that's going to be 2, then we have 52 here, okay, so that's going to be 52, 18 over 52. Okay, so and we can simplify this. 2 into 18 is a 9, then 2 into 52 is actually 26. Okay, so this part as well, we can simplify it to 9 over 26. Okay, now the last part. So the last part is f of 5 over 3. So we have 2 over 5 over 3 squared plus 4 is equals to, we have 2 over 25 over 9 plus 4 divided by 1, and once again make this a single fraction, so this is going to be equals to 2 divided by 25 plus 36 divided by 9, that will be equals to 18 divided by what's that going to be, is it 61? We are going to get, yeah, we're going to get 61 here, so it's 18 over 61. Are we able to simplify that? Nah, I think we'll leave it the way it is, 18 over 61, like that. So what we have now, all of this, if you punch this on your calculator, all of it, you're going to end up with something like 3.9 9554446, like that. Okay, so that's basically what the middle part gives us. So we can now bring it back here. So we can say this is equals to, what is our h? Our h is 1 over 3. So if you plug in 1 over 3 here, that's going to be 1 over 6. Okay, 1 over 6. Then here we have 1 over 2, which is 0.5 plus. Here we observe that we ended up with 3.9554446. There's another 4. 6, and mind you, I haven't forgotten about the 2. If you punch in your calculator including the 2, that's what gives you 3.9554446. Okay, then we say plus 1 over 4. So having done this, you're going to end up with this value that is like 0.784240766. Okay, that's a value that you're going to end up with. So we can make our conclusion. We can make our conclusion to say by composite trapezoidal rule, 0 to 2 of the integral of the function 2 divided by x squared plus 4 dx is approximately equals to 0.784240766. That's what we get. So what are we able to do from here? From here now we can come up with our error. Okay, so our error is simply equals to the absolute value of the exact value. Okay, exact value minus the approximation. Okay, minus the approximation, that will be equals to, what's our exact value? Our exact value is equals to 0.785398163 minus 0.7842407661. So our error turns out to be equals to 0.001157396 like this, and this is our error. So we have come up with our approximation, which is this one. We came up with the exact value, which is that one, and from these two we have come up with our error, which is this one right here. So that's all. That was all for part A. Let's now go to part D, which is asking us to determine n and h to within this accuracy, the degree of accuracy given as 10 to the power negative 5. Okay, so how do we work this out? Okay, so how we work this out is pretty simple and straightforward. So all we need to do is to use the error part of the trapezoidal rule. So the error part of the trapezoidal rule E is indicated as minus b minus a divided by 12 multiplied by h to the power 2. Then we have f prime prime of mu there, like that. Okay, so one thing you observe is that you already have your b, you already have your a, like your h is the one you're looking for. So from this we just have to find the second derivative of our function. So our function we are given as f of x is equals to 2 over x squared plus 4, but I'm not going to write it like this. Okay, I'm going to write it as 2 multiplied by x squared plus 4 to the power negative 1. Okay, meaning my first derivative f prime of x is just going to be equals to, the power is going to drop, that is negative 1, that would be 2 by negative 1 multiplied by the derivative of the inside part, which is 2x. I'm using the chain rule, by the way, so that's going to be x squared plus 4, the power reduces by 1, that's going to be negative 2. Okay, so this can actually be written as minus 4x, then you have x squared plus 4 to the power negative 2. So here the second derivative, because that's what we need to use. So if f prime prime of x is equals to, the power again is going to drop, like we have minus 4. And by the way, here you're using the chain rule and the product rule, because this now becomes a product of two functions. There is this function here and there is this other function here. So by using the product rule, let me differentiate minus 4x, that's going to be minus 4. Then I write the other one the way it is as x squared plus 4 to the power negative 2, like that. Then I'll say plus, I keep minus 4x the way it is as minus 4x. Okay, then let me differentiate the other part, that is 4x. Let me differentiate the other part. The power is going to drop, which is minus 2, multiplied by the derivative of the inside part, which is 2x. Then you have your x squared plus 4 to the power reduces by 1, that would be minus 3. So this can be written as we have minus 4. Okay, let me try to write it this way. This will be equals to, we have minus 4 divided by, we have x squared plus 4 to the power 2 or squared. Then here we're going to have plus, because this negative times this negative is going to be positive. So we have 4 times 2, 8 times 2, we have 16. Then x times x, that would be x squared. So that's going to be 16x squared divided by x squared plus 4 to the power 3. You can write this as a single fraction. So the common denominator is x squared plus 4 to the power 3. Okay, meaning here we're going to have minus 4 multiplied by x squared plus 4. Okay, then we say plus 16x squared. What does this now become? You're going to have minus 4x squared minus 16. Okay, minus 16 plus 16x squared divided by x to the power 2 plus 4x to the power 3, like this. So minus 4x squared plus 16x squared, we're going to end up with 12x squared minus 16 divided by x squared plus 4, and all of this is raised to the power 3. So that's what we get as our second derivative. Okay, so we have gotten that our f prime prime of x is simply equals to 12x squared minus 16 divided by x squared plus 4 to the power 3. Okay, meaning we no longer need all of this. Okay, so now what is left now is to evaluate f prime prime of x at at our interval. The interval that we are given in the question is 2, I mean 0 comma 0 comma 2. Okay, so now let's try f prime prime at 0. Okay, what would this be? That would be like 12 multiplied by 0 squared minus 16 divided by 0 squared plus 4 to the power 3. That is going to be equals to minus 16. 4 to the power 3 is like 4 times 4 is 16. 16 times 4, that is going to be 64. Which actually in decimal places that's going to be minus 0.25. What about f prime prime at 2? What is it going to be? You're going to have 12 multiplied by 2 squared minus 16 divided by 2 squared is a 4. 4 plus 4 is 16. Sorry, 4 plus 4 is 8. 8 to the power 3 is 512. Okay, like you are saying 8 times 8 times 8. 8 times 8 is 16 times 8, that's going to be 512. Okay, so from this what are we going to end up with? So 2 squared is a 4. 4 times 12 is 48. Okay, 48 minus 16, that's going to be 32. Hope I've done the correct thing there. So divide by 512, then this is going to be more like 0.0625, like that. So now, what value are we going to use? Okay, so why am I asking to say what value are we going to use? But first of all, let me write these in terms of absolute values, like f prime prime, like the absolute value of f prime prime of 0 is equals to, meaning the positive value of that's going to be 0.25. So the absolute value of f prime prime at 2 is simply equals to the same 0.0625. So we observe to say this one is bigger. So why am I looking for the bigger one? It's because the error that we are looking for can be more like in the form we say absolute value of the error e, okay, is supposed to be more like less than or equal to you have your b minus a divide by 12, then you have your h to the power 2, then multiplied by the maximum value, okay, the maximum value of, in this case, since I'm using mu, I'll say for mu within the interval 0 comma 0.2, but so that's supposed to be a comma b, but since you already know what it is, so multiply by the maximum of the absolute value of f prime prime, okay, f prime prime of mu or x. Let me just put x here like this. Okay, so that's what that means. So you observe to say the maximum value is what? Is 0.5. So we can write to say our maximum is 0.25, like that. Okay, so let's go ahead and now use this. So having said that, we are going to say we are just going to pick this part, and it's the absolute value, meaning we no longer have to worry about that negative sign. So b minus a is like 2 minus a, and I mean 2 minus 0, that's going to be 2. 2 divided by 12, that's 1 over 6. So that's going to be 1 over 6. Then we're going to say our h here, okay, multiplied by 0.25. This is going to give us h squared divided by 6 divided by 0.25 is going to be 24, like that. So like I've just multiplied both the numerator and the denominator by 1 over 0.25. Okay, so now remember, this here is supposed to be within the required error of accuracy. That's going to be 10 to the power negative 5. So you're just going to say your h is supposed to be less than 24 by 10 to the power negative 5. If you punch that on your calculator, you're going to end up with the value of h being equals to 0.015491933. So to get our n is simply what our n is. How do we get our n for this? Okay, it's also pretty straightforward how we get our n, because we know that our h is equals to b minus a over n. So we can say n is equals to b minus a over h. Okay, what is our b minus a? Is 2, because 2 minus 0 is a 2, divided by h. Our h that we already have, that's going to be like 0.015491933. You're going to end up with your value of n to be equals to something like 129.0994481, like that. Okay, so if you write that to the nearest whole number, so that's just going to be n is equals to 130. So this is your n and that is your h, and that's basically how we answer this question. Thank you very much for watching, and we'll catch you in the next video.